In example 5, we are told that OABC is a parallelogram and P is the point where the diagonals OB and AC intersect. OABC is a parallelogram, as you can see, and P is the point where the diagonals OB and the diagonal AC intersect. The vectors A and C are equals to OA and OC respectively. So this is vector A, as you can see, and this is vector C, as shown there. Prove that the diagonals intersect each other. The question is, prove that the diagonals intersect each other. Prove that the line OB and the line AC intersect each other at point P. To prove that, you must show that the properties of intersection, of course, we will have to show that P is the midpoint of both vector OB and AC. We have to show that. This follows that we must prove that OP is equals to PB and AP otherwise is also equals to a half AC. We have two vectors OB. We have two diagonals. OB is equals to, from here all the way to B, is given by OA plus AB. And of course you can see AB is the same as C. These are parallelogram. Opposite sides equal and parallel. This is going to give us A plus C. This is vector OB. Another vector we are supposed to consider is the other diagonal, which is AC, which is AO plus OC. And of course you can see AO is the opposite of OA, which is minus A plus C. After that, we will have now to consider the position of point P. Of course, you can see point P is lying between OB. Now that P lies on OB, we can easily say that OP is a fraction, call it lambda, of OB, which is lambda, and OB is A plus C. That one is when we are moving direct from O to P. But again, we can also follow a different route from O to P, and that could be OA plus AP. OP is also on line AC. So we'll have to design another route that is going to use AC. And that route is OP is equals to OA plus AP. Is equals to OA plus AP. But we know OA. OA is A. And we know we are going to AP is a fraction of AC. Let's call it mu. And let's call it mu AC. But what is AC? According to us, our AC is minus A plus C. So OP is going to be A plus mu C minus A. And because now we have two expressions of OP, we have OP is equals to lambda A plus C, and we have OP being equals to A plus mu C minus A. And because we are talking about the same OP here, which is still appearing here, then this OP is also equals to this because it's the same thing. So OP, or rather lambda A plus C, which is this AC, is equals to A plus mu C minus A. If you open this bracket, you're going to have lambda A plus lambda C, which is A minus mu A plus mu C. Of course, because the two sides are equal, the left-hand side is equals to the right-hand side, then all components of A on the left-hand side should be equals to all components of A on the right hand side, and all components of C should be equals to all components of C on both sides. This is equals to, if we have lambda A is equals to A 1 minus mu, because if we combine both the A's there will give us, what does this mean? This means that if you divide by A both sides, then lambda is equals to 1 minus mu. Call it equation 1. We have realized that after comparing all the components of A. Let us go and compare all the components of C. They are very straightforward. From there, then we are going to have lambda C is equals to mu C. And if you divide by C both sides, then lambda is equals to mu. If we substitute this here, and for example, if we come across lambda, we write mu, then because lambda is equals to mu, then we're going to have mu is equals to 1 minus mu. If we cross over this side, then we're going to have 2 mu is equals to 1. Divide by 2, then mu is equals to half. Having realized this, we must also remember, but lambda is equals to mu. So mu is equals to lambda, both of which are equals to a half. Going back to our probably original expression, probably here, and we are going to express OP in terms of so OP, substituting the value of lambda there, is going to be equals to a half OB. That shows very well that OP is a half of OB. What if we followed the other route, which is talking about OP is equals to A plus mu C minus A, but mu is also half. Let us consider that. If we put it just across here, we are going to say OP is equals to A plus a half C minus A. If you open this bracket, you're going to have OP is equals to A plus a half C minus a half A. A minus a half A, you're going to find that OP is a half A plus a half C. Meaning that, in a nutshell, then we can easily say which is equals to this, because A plus C also becomes OB. And with that, having found out that P lies exactly at the midpoint of OB, then we can easily conclude that the two diagonals bisect each other. All right?